In this lesson, we solve problems in 2 and 3 dimensions. We use knowledge learned in trigonometry to solve problems in 3 dimensions. At the end of this lesson, we should be able to define angle of elevation and angle of depression. We should be able to use sine rule, area rule, cosine rule to solve problems in 3 dimensions. We should also be able to utilize compound and double angles in solving problems in 3 dimensions. Let's look at this diagram which illustrates 3 different planes: vertical plane, horizontal plane, and inclined. Right, if you look at side CD, which is perpendicular to the horizontal plane, so we have 4 triangles out of this diagram. So 2 triangles from which forms part of the vertical planes are right-angled triangles, and the inclined plane triangle is not a right-angled triangle, and triangle ADB is also not a right-angled triangle unless you are told. To solve this type of equation or this diagram, so we need the definition, the trigonometric definitions and triangle rules. Your sine, cos, and tan, since we have right-angled triangles. We'll also use the sine rule, cosine rule, and area rule. It is also important to remember our angle of elevation and depression. Right, so we have our horizontal side is when you're looking straight. When your eye rotates up, it forms angle of elevation. And when your eye rotates down, it forms angle of depression. Let's look at this diagram. In the diagram, AD represents a flagpole of length 5 meters, which is perpendicular to the horizontal plane. An observer at C knows that the angle of elevation of D is 35 degrees, while another observer at B in the same horizontal plane as C finds that the angle of elevation of D is 42 degrees, BAC is 65. It is important to note that 3-dimensional problems are solved in the same way that 2-dimensional problems are. Identify what information is given with regard to sides, angles, and then use the appropriate rules to calculate the length of sides and angles. Right, from the triangle, we know that triangle CAD equals to is a right angle triangle, and triangle BAD is a right angled triangle. It is also important to note that the flagpole is perpendicular to the horizontal plane, and therefore it will be perpendicular to any point that lies on that plane. Therefore, to answer the question, what are the angles DAC and DAB equals to? DAC equals to 90 degrees and DAB equals to 90 degrees. Right, the next question. How far is each observer from the foot of the flagpole round of two decimal places? So here we are asked to calculate the length of AC and AB. Right, so we are supposed to calculate the length of AC and AB. Right, so since we are given that triangle CAD is 90 degrees, is a right angle triangle, and triangle BAD is a right angle triangle. Therefore, angle ADC equals to 55 and angle ADB equals to 48 using the sum of angles of a triangle. Therefore, to calculate side AC and side AB, we'll use sine rule since we have more than one angle and one side. Right, in triangle ADC, sine A over A equals to sine D over D equals to sine C over C. Right, so sine 55 over AC equals to sine 35 over 5. Then we multiply out, cross multiply. Therefore, AC equals to 7,14. To calculate AB, we use triangle DAB. We substitute using sine rule. Sine 48 over AB equals to sine 42 over 5. And then you cross multiply, you solve. Therefore, AB equals to 5,55 meters. The next question. Calculate the distance between the two observers at C and B. Leave your answer to 2 decimal places. Right. In triangle ABC, there are 2 sides and included angle. The cosine rule will be appropriate rule to use to calculate the length of BC, since we have 2 sides and included angle. So BC squared equals to AC squared plus BC squared minus 2 AC times BC cos A. Then we substitute BC squared equals to 7,14 plus 5,5 minus 2 times 7,14 times 5,55 times cos 65. Right, to get the answer here, you just use your calculator and then you get 48,287,91228. Then we introduce square root, therefore BC equals to 66,95 meters. The next question, calculate the area of ABCD to the nearest whole number. Right, so since we are calculating the area, we're going to apply the area rule. Area rule, half BC, half AC times AB sine A. Then we substitute, then it gives us 18 meters. Right, let's look at the next question. In the diagram, PQ is perpendicular to the horizontal plane RQS, and QS, which is side, is X meters. QRS equals to theta, is the angle QRS, and then QSR equals to beta, and the angle of elevation of P from R is theta. So this term we were not given the size or the length of sides. We're given in terms of theta, beta, alpha, and x. So the first question says, determine the length of RQ in terms of alpha, beta, and x. So it means we must answer RQ in terms of alpha, beta, and x. Right, if you look at RQ, so RQ is common to 2 triangles, which is triangle PRQ and triangle RQS. But if you look at triangle PRQ, we don't have enough information in terms of theta, beta, and x. But triangle RQS has both theta, beta, and x. Therefore, we should start by looking at triangle P, triangle RQS. Right. So in triangle RQS, your QRS equals to alpha and QSR equals to beta. Right. Using the sine rule, sine Q over Q equals to sine R over R, sine S over S. Right. More than one angle and one side is given. So therefore, we know that angle Q equals to 180 minus theta plus alpha. So if you check triangle RQS, we know alpha, we know angle QRS and angle QSR, which is alpha and beta. And we also know side X. And therefore, we'll use sine alpha over X equals to sine beta over RQ. And then we cross multiply, we get RQ sine alpha equals to X sine beta. Therefore, RQ equals to X sine beta over sine alpha. Therefore, our answer is in terms of X, beta, and sine alpha. Right. You must always choose the two that have the most information and contain side which we are looking for. So you must always have only one unknown. The next question. Hence, show that PQ equals to X sine beta tan theta over sine alpha. Right. If you look at PQ, is in triangle PRQ, and P equals to 90 minus theta in terms of sum of angles of a triangle. So we're going to use our sine rule since we have more than one angle and one side. So we'll use sine 90 minus theta divided by RQ equals to sine theta over PQ. Don't forget that our sine theta, sine 90 minus theta equals to cos theta. Right. Then we also know RQ. Or first we can start by cross multiplying. Then we have PQ cos theta equals to RQ sin theta. Therefore, PQ equals to RQ sin theta cos theta. Right. Then what is sin theta over cos theta? Sin theta over cos theta equals to tan theta. Right. And we also know that RQ from the previous proof is equals to x sin beta over sin alpha. Therefore, PQ equals to x sin beta over sin beta over sin alpha times tan theta by substituting RQ. Right. Next, we go to the next. In the next question, we are going to utilize our compound and double angle to answer our 3 dimensions question in. Right. Let's look at the question. In the figure alongside, A, B, C are 3 points in the same horizontal plane. AD is a lamp pole that is perpendicular to the horizontal plane. Given angle BDA equals to angle ABC, which is equals to theta. And BCA equals to beta. And BC equals to x. Write BAC in terms of theta and beta. Show that AB equals to x sine beta divided by sine alpha over beta. If AB equals to AC, show that AB equals to x over cos 2x. Number 2, AD equals to x over sine. Right, to write BAC in terms of alpha and beta, we look at triangle BAC. In triangle BAC, angle A equals to 180 minus alpha plus sine beta, sum of angles of a triangle. Right, number B, show that AB equals to x sine beta over sine into alpha plus beta. Sine alpha plus beta. Right, so here we're going to use our sine rule because more than one angle and one side is given. Right, so we'll use sine 180, which is sine A over x equals to sine B, sine beta over AB, because we are looking for AB. Right, so we know in terms of reduction formula, 180 minus sine is in the second quadrant and sine is positive in the second quadrant. Therefore, we'll have sine theta plus beta over x. Right. Then we cross multiply. Then we solve for b. Then we have x sine beta over sine alpha sine theta plus. Right. We go to C. But in the next question, we want to use the previous question to calculate AB and AD. Given that AB equals to AC, AB equals to AC. Right. So since AB equals to AC, we know that our angle beta equals to angle theta. Reason being, angles opposite equal sides. Therefore, we go back to letter B, the previous question. AB will be equals to x over sine beta. Then we substitute beta with theta. Then from there we have AB equals to sine theta over sine 2 theta. We change our sine 2 theta, since sine 2 theta is a double angle, we change it into 2 sine theta cos theta. And then your sine theta cancels sine theta. We are left with x cos 2, x over 2 cos. Right, in the next question, number 2, we want to prove that AD equals to x over 2 sine theta. If you look at AD is in triangle ADB. And in triangle ADB, your angle B equals to 90 minus theta. So we're going to use our sine rule to answer this question. So sine 90 minus theta, which is angle DBA over AD, equals to sine theta over AB. We have AB. Right. Therefore, so we know that sine 90 minus theta equals to cos theta over AD equals to sine theta over AB. Then we cross multiply. AB cos theta equals to AD sine theta. Therefore, AD equals to AB cos theta over sine theta. Then we know that AB is equals to x over 2 cos theta. Then cos theta cancels cos theta. Then our final answer will be AD equals to x over cos 2 theta. Right. You can go to different textbooks like Platinum. This section or topic is in page 121 of Platinum and 153 of Classroom. Thank you very much. Enjoy.